And now in this lecture we will find out the radius of the circle. In the drawing we have a big semicircle. Inside this big semicircle we have two smaller semicircles and one circle. We also know that the length of this line segment is equal to 140 units and this line segment equals to 70 units in its length. Our mission is to find out the radius of this circle. Okay, so first of all we will define names to the relevant points here. This point will be defined as A, the center of this semicircle will be defined as B, the center of the biggest semicircle will be defined as O, the touching point between those two semicircles will be defined as C, the center of the smallest semicircle will be defined as D, the touching point of the biggest semicircle with the smallest semicircle will be defined as E, the center of this circle will be defined as F, the touching point of the smallest semicircle with the circle will be defined as G, the touching point of this semicircle with this circle will be defined as H, and finally the touching point of this circle with the biggest semicircle, this touching point will be defined as I. In the next step, we will define the radius of the biggest semicircle as capital R. And we will define the radius of this circle as small r. The radius of the circle, that is the radius that we are looking for. Actually, it is given us the question that the length of line segment AE equals to 140 units plus 70 units. So AE equals to 140 plus 70, it is actually 210 units. AE equals to 210 units. But what is actually line segment AE? It is very easy to see that line segment AE, it is the diameter of the biggest semicircle. Okay, AE is the diameter of the biggest semicircle. And we know that the diameter of any circle or semicircle is twice as long as the radius. Because of the fact that we define the radius of the biggest semicircle as capital R, it means that the diameter must be equal to 2 times capital R. And from this long equation, we will derive that 2 times capital R equals to 210. Here we will divide this equation by 2 and we will get that capital R, that is to say the radius of the biggest semicircle, equals to 210 over 2, that is 105 units. Okay, capital R equals to 105 units. We can write down here that the radius AO equals to 105 units. Why AO is the radius of the biggest semicircle? Because of the fact that it starts from the center of the biggest semicircle and ends at point on the biggest semicircle itself. Therefore, AO is the radius of the biggest semicircle, that is equal to 105 units. Likewise, for the same reason, OE will be also the radius of the biggest semicircle, that is equal to 105 units. Okay, again, line segment OE starts from the center of the biggest semicircle and ends at point E, that is the point of the biggest semicircle itself. Therefore, this is exactly the definition of a radius. Therefore, OE is the radius of the biggest semicircle, that is equal to 105 units. Okay. It is given us in the question that line segment AC equals to 140 units. But what is line segment AC? Line segment AC, it is the diameter of this semicircle. It is the diameter of this semicircle, and therefore the radius must be equal to half of it. That is to say, the radius of this semicircle equals to 140 over 2, that is 70 degrees. So the radius AB equals to 70 units in its length of this semicircle. And the radius, it is also BC, and BC it is also equals to 70 units. Likewise, it is also given us in the question that line segment CE, this line segment CE equals to 70 units in its length. But what is line segment CE? CE is the diameter of the smallest semicircle, and therefore the radius of the smallest semicircle must be equal to half of it. That is to say, the radius of this smallest semicircle equals to 70 over 2, that is 35 units. That is to say, the radius CD equals to 35 units, and the radius DE of the smallest semicircle, it is also equals to 35 units. In the next step, we'll find out the length of line segment BO. Okay, so BO equals to from the drawing, it is very easy to see that BO equals to OA minus BA. OA minus BA equals to BO. OA minus BA. So BO equals to OA is the radius of the biggest semicircle, that is equal to 105 units. So we substitute OA by 105 minus BA. BA is the radius of this semicircle, that is equal to 70 units. So we substitute BA by 70. So we actually found out that the length of line segment VO equals to 105 minus 70, that is 35 units. VO equals to 35 units. in its length, so we can write down in the drawing that BO equals to 35 units in its length. In the next step, we'll find out the length of this line segment OC. Okay, so the length of line segment OC from the drawing, it is very easy to see that the length of this line segment OC equals to OE minus CE. Again, OE minus CE equals to OC. So it is OE minus CE. Okay, OE minus CE equals to OC. OE minus CE equals to OC. So OC equals to OE. Here OE is the radius of the biggest semicircle, that is 105, so we substitute OE by 105 minus CE. CE equals to 70 units according to what is given us the question. CE equals to 70 units. So we substitute CE by 70. So in conclusion, we found out that the length of line segment OC is 105 minus 70, that is 35 units. OC equals to, line segment OC equals to 35 units in its length. So we write down in the drawing that OC equals to 35 units in its length. OC equals to 35 units in its length. In the next step, I will present to you two new rules, and we will implement the two new rules in our drawing. The first rule is rule number 10. According to rule number 10, if two circles are touching each other internally, then the straight line that connects their centers together passes through their touching point. So in this drawing we have two circles. The small circle is located inside the big circle. Therefore, those two circles have an internal notch between them at point N. That is to say, they are touching each other internally at this point N. And according to this rule number 10, the straight line that connects their centers together, the center of the big circle is at point O, and the center of the small circle is at this point M. And the straight line that connects their centers together is ON. So this straight line ON passes through their touching point. Their touching point is at point N. That is to say, OMN is one straight line. OMN is one straight line. Okay, so whenever you have an internal notch between two circles, then the straight line that connects the centers together must pass through their touching point. In this case, the straight line OM that connects their centers together must pass through point N. That is to say, OMN is one straight line. And because of the fact that OMN is one straight line, it means that the distance between their centers OM must be equal to capital R, that is the radius of the big circle, minus small r, that is the radius of the small circle. So capital R minus small r equals to MO, that is the distance between their centers. D equals to capital R minus R, the distance between their centers MO equals to D, that is capital R minus small r. Then we actually have also rule number 11. According to rule number 11, if two circles are touching each other internally, those two circles are touching each other externally. Why? Because they are not one inside the other. Each of them are not located inside the other, therefore they are touching each other externally at point N. So they have an external notch between them at point N. Okay? And according to this rule number 11, the straight line that connects their centers together, point O is the center of the big circle, point M is the center of the small circle, and the straight line that connects their centers together is MO or OM. OM, according to this rule number 11, must pass through their touching point, that is to say, for point N. Point N is the touching point, and therefore line segment OM must pass through point N. That is to say, O and M, line segment O and M is one straight line. On the 3 points O, N and M are located on one straight line. O and M is one straight line. Okay? And what is the distance between their centers? The distance between their centers is OM. And from the drawing it is very easy to see that the length of line segment O and M, that is OM, the length of line segment OM, that is the distance between their centers, it is equal to ON, that is capital R, plus ONM, that is small r. That is to say, OM equals to capital R plus small r. So the distance between their centers, OM, that is equal to D, equals to capital R plus small r. Capital R plus small r. Okay, so we can actually implement the two new rules in our drawing. Well, because in our drawing, point B is the center of this semicircle. Point F is the center of this circle. And the straight line that connects their centers together is FB. The straight line FB, according to rule number 11, must pass through their touching point, that is actually point H. Point H is their touching point, and the straight line FB that connects their centers together must pass through point H. That is to say, FHB is one straight line. FHB is one straight line. So you can draw here. FHB is one straight line. But what is the definition of line segment FH? Point F is the center of this circle, point H is the point on the circle itself, therefore this is exactly the definition of radius. So FH is the radius of this circle, that is equal to small r according to our definition. FH equals to small r. And what is BH? B is the center of this semicircle, edge is the point on this semicircle itself, therefore B edge is the radius of this semicircle, that is equal to 70 units. And therefore, the distance between their centers B edge will be equal to 70 plus R. BF equals to B edge plus edge F. So BF equals to B edge, that is 70, plus edge F, that is R. So BF equals to 70 plus R. Is 70 plus R. BF equals to 70 plus R. Likewise, we will connect the center of the smallest semicircle, that is to say point T, with the center of this circle, that is point F. So we will connect points F and D together by straight line. So the circle have an external notch with the smallest semicircle at point G. That is to say at point G, those two circle and semicircle are touching each other externally at point G. So they have an external notch between them at point G. Therefore, the straight line that connects their centers together, FD, must pass through point G. That is to say, FGD is one straight line. FGD is one straight line. Point F is the center of this circle. Point G is the point on the circle itself. Therefore, FG is the radius of this circle that is equal to small r. Here, point D is the center of the smallest semicircle. Point G is the point on the smallest semicircle itself. This is exactly the definition of a radius. So GD or DG is the radius of the smallest semicircle that is equal to 35 units. Therefore, we actually found out that FD, that is the distance between the centers of the circle and the semicircle, it is equals to 35 plus r. FD equals to 35 plus r. And what is the length of line segment BD? From the drawing, it is very easy to see that BD equals to 35 plus 35 plus 35. Again, BD equals to BC, that is 35, plus CO, that is 35, plus OV, that is also 35. So BD equals to 35 times 3, that is 105. BD equals to 105 units. In the next step, we join the center of the biggest semicircle that is located at point O with the center of this circle that is located at point F. So we join points O and F together by a straight line. The biggest semicircle has an internal notch with this smallest semicircle at point I. That is to say, they are touching each other internally at point I. Why? Because of the fact that the smallest semicircle is located inside the biggest semicircle, and therefore they have an internal notch between them at point I. And according to rule number 10, the straight line that connects their centers together, that is to say, the straight line OF must pass through point I, or OFI is one straight line. Again, OFI is one straight line, according to rule number 10. OFI is one straight line, so here we have point F is the center of the circle. Point I is the point on the circle itself. This is exactly the definition of a radius. So Fi is the radius of this circle that is equal to small r. So Fi equals to small r. What is the definition of line segment OI? Point O is the center of the biggest semicircle. Point I is the point on the biggest semicircle itself. This is exactly the definition of a radius. So OI equals to capital R, and we have already found out that capital R equals to 105 units. Okay, so in conclusion, we found out that Fi equals to small r and OI equals to capital R, that is equal to 105 units, according to what we have already found out. And what is the length of line segment OF? Here, the length of line segment OF. OF equals to OI minus Fi. Again, OI minus Fi equals to FO. OI minus Fi equals to FO. Okay, repeat again for drawing. It is very easy to see that FO, this line segment FO equals to OI minus Fi. So Fo equals to Oi minus Fi. So Fo equals to Oi is 105 units. So we substitute Oi by 105 minus Fi. Fi equals to R. So we substitute Fi by small r. It's a small r. In conclusion, we found out that Fo equals to 105 minus r units. Fo, this line segment Fo equals to 105 minus small r units. So in the next step, I will present to you a new rule, and we will implement the new rule in our triangle FBD. Repeat again, we will implement the new rule in triangle FBD. This triangle FBD. The new rule is Stewart's theorem, and Stewart's theorem is true in any triangle. Stewart's theorem is true in any triangle, so the triangle that I will draw could be any triangle. This is triangle ABC. This could be any triangle. We know that the length of side AB, this side, is equal to A units. Side AC equals to B units in its length, and finally side BC equals to C units in its length. BC equals to C units in its length. And we also have a line segment AO that is equal to D units in its length. We also know that line segment BO equals to M units, and line segment OC equals to N units in its length. Okay? According to Stewart's theorem, in this triangle that could be any triangle, the following equation will be true. A squared times n, A squared times n, plus B squared times m, plus B squared times m, equals to C. C is the length of side BC. And in the brackets we have D squared. D is the length of OEO, so it is D squared plus M times N. I repeat again, in this triangle ABC that could be any triangle, according to Stewart's theorem, the following equation will be true, that A squared times N plus B squared times N equals to C. In the brackets we have D squared plus Mn. We actually can implement Stewart's theorem in our green triangle BFD. So I'll copy the green triangle BFD in a new page, and we will implement on it Stewart's theorem. We have already found out all the sides of this rectangle, and we also found out that Fo equals to 105 minus r units. side FB, this side FB equals to 70 plus R units. Side FD, this side FD equals to 35 plus R units. We already found out that side VD equals to 105 units, so I will not repeat on it. AO equals to 105 minus R units. FO, it is FO is equal to 105 minus R units. It is very easy to see that the length of line segment BO equals to 35 units. And the length of this line segment OD is 35 plus 35, that is 70 units. So actually, this is triangle FBD. With the comment from the original drawing, we'll implement on it Stewart's theorem. According to Stewart's theorem, this triangle FBD, FB squared times DO plus FD squared times BO equals to BD times, inside the brackets we have FO squared plus BO times OD. BO times OD. Repeat again according to, so this equation is the implementation of Stewart's theorem in our triangle FBD. According to Stewart's theorem, in this triangle FBD, FB squared times DO plus FD squared times BO equals to BD. Inside the brackets we have FO squared plus BO times OD. FB equals to 70 plus R, therefore FB squared is 70 plus R squared times DO. DO equals to 70, so we substitute DO by 70 plus FD squared. FD equals to 35 plus R, therefore FD squared equals to 35 plus R squared times BO. BO equals to 35, so we substitute BO by 35, and it is equal, in the other side of the equation we have BD equals to 105 units, according to what we have already found out. Inside the brackets, we have FO squared. f(o) equals to 105 minus r, therefore f(o) squared equals to 105 minus r squared plus b(o) is 35 times od is 70. Okay. In the next step, we will define the number 35 as x, and we will substitute 35 in our equation 35, or any multiplication of 35 by a natural number, we'll substitute it by x. Okay, and you will get it in our equation. We have here 70 is 35 times 2, or 2 times 35, therefore we substitute 2 times, we will substitute 35 by x, therefore 35 times 2 is 2x plus r squared times 70. 70 is 35, 2 times 35, therefore it is actually 2 times x plus 35 plus r squared is x plus r squared times 35 is x, so we'll substitute 35 by x. And it is equal to, on the other side of the equation, we have 105. 105 is 3 times 35. 3 times 35 is 3x. Inside the bracket we have again 105, that is 3x, minus r squared plus 35 is x, 70 is 2 times 35, that is 2x. So in total, this expression equals to x times 2x. So after we substituted 35 by x, we got this equation. In this equation, we divide this equation by x. Okay. Here, x will get cancelled. Here also x will get cancelled. And here x will get cancelled. So what is left from this equation after we cancelled x? On this side of the equation we have 2x plus r squared times 2 plus x plus r squared equals to 3. Inside the brackets we have 3x minus r squared plus x times 2x is 2x squared. Okay. Here we'll open the brackets. We have 2 times 2x plus r squared equals to 2x squared, that is 4x squared, plus r squared, plus 2 times 2xr, it is 4xr, plus x plus r squared equals to x squared plus r squared plus 2xr and it is equal. On the other side of the equation we have 3, and inside the brackets we have 3x minus r squared, according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2ab. We get that 3x minus r squared equals to 3x squared, that is 9x squared, plus r squared minus 2 times 3x times r is minus 6xr, plus 2x squared. Here we will open the brackets, we will multiply by 2 all expression inside the brackets. 2 times 4x squared is 8x squared, plus 2 times r squared is 2r squared, plus 2 times 4xr is 8xr, we have here plus x squared, plus r squared, plus 2xr equals to, here we will open the brackets on the other side of this equation, but before we will open the brackets, we have inside the brackets we have 9x squared plus 2x squared is 11x squared, plus r squared minus 6xr. Okay. On the other side of the equation we have 8xr plus 8x squared plus x squared is 9x squared, plus 2r squared plus r squared is 3r squared, and 8xr plus 2xr is 10xr. And in the other side of the equation we'll open the brackets, we'll multiply all the expressions inside the brackets by 3. Okay. 3 times 11x squared is 33x squared, plus 3 times r squared is 3r squared, and finally 3 times minus 6xr is minus 18xr. So here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step, we will subtract 9x squared from this equation. 9x squared minus 9x squared is 0, so we left only with 8xr. In the other side of the equation, we have 33x squared. 33x squared minus 9x squared is 24x squared. Minus 18xr. So in conclusion, we found out that 10xr equals to 24x squared plus 18 minus 18xr. Here we will add 18xr to this equation, and we will get that 10xr plus 18xr is 28xr, and it is equal to 24x squared. 18xr minus 18xr is 0. So in conclusion, we found out that 28xr equals to 24x squared. Here we divide this equation by x, and we will get that 28xr over x is 28r, 24x squared over x is 24x. In conclusion, we found out that 28r equals to 24 times x. Here we will substitute x by 35 because of the fact that according to our definition x equals to 35, and we get that 28r equals to 24 times x, and x is 35. In the next step, so we found out that 28r equals to 24 times 35. Here we will divide this equation by 7. 28 over 7 is 4, so in total this side of the equation we have 4r. That is equal to 24 times 35 over 7 is 5. So in total, this side of the equation we have 24 times 5. So we found out that 4r equals to 24 times 5. Here we will divide this equation by 4, and we get that 4r over 4 is r, and 24 over 4 is 6. So in total, this expression, in this side of the equation, we have 6 times 5. So r equals to 6 times 5, that is 30. So r equals to 30 units. Okay? So we actually found out that the radius that we are looking for, the radius of this circle equals to 30 units in its length. In the next step, I will summarize the lecture. In the drawing, we have a big semicircle. Inside this big semicircle, we have two smaller semicircles and one circle. We know that line segment AC equals to 140 units in its length. Line segment CE equals to 70 units in its length. And our mission is to find out the radius of this circle. Okay, so first of all, we define the sides of all the relevant, we define the relevant points in this drawing. A, the center of the circle is B, the center of the biggest semicircle is at point O. This, the touching point between those two semicircles is defined as C. The touching point of the smallest semicircle with the biggest semicircle is defined as E. The center of this circle is defined as F. Okay. The touching point between this circle with the smallest semicircle is G, and the touching point of this semicircle with this circle is defined as H. And in the next step, we define the radius of the biggest semicircle as capital R, and the radius of the small circle as small r. Okay? Capital R is the radius of the biggest semicircle, and small r is the radius of the circle. But it is actually given us in the question that the length of line segment AE is 70 plus 140. AE equals to 140 plus 70, that is 210. So the length of line segment AE is 210 units. But what is AE? AE is the diameter of the biggest semicircle. It is very easy to see it from the drawing. Okay? That is to say, AE equals to 2 times capital R. Why? Because of the fact that the diameter of any semicircle or circle is twice as long as the radius. So we define the radius of the biggest semicircle as capital R, therefore the diameter must be equal to 2 times capital R. Okay? So the diameter of the semicircle is 2 times capital R, and the diameter is actually AE, and we already found out that A equals to 210 units. So from this long equation we will derive that 2R equals to 210, 2 times capital R equals to 210. We divided this equation by 2 and found out that the radius of the biggest semicircle, capital R, equals to 210 over 2 is 105 units. Here the radius OA is 105 units, and the radius of the biggest semicircle OE, it is also equals to 105 units. Okay, and we also know that line segment AC equals to 140 units according to what is given us the question. But what is line segment AC? AC is the diameter of this semicircle, and if the diameter of the semicircle AC equals to 140 units, it means that the radius must be equal to half of it. That is to say, the radius AB of this semicircle equals to 140 over 2, that is 70 units, and the radius BC here also it is equals to 70 units. Likewise, it is given us the equation that line segment CE equals to 70 units. But what is line segment CE? CE is the diameter of this smallest semicircle. So if the diameter of the smallest semicircle equals to 70 units, it means that the radius must be equal to half of it. That is to say, it must be equal to 70 over 2, that is 35 units. So the radius DE of this smallest semicircle equals to 35 units, and the radius CD of this smallest semicircle, it is also equals to 35 units. Okay, in the next step, we found the length of this line segment BO. What is the length of line segment BO? From the drawing it is very easy to see that BO equals to OA minus BA. Again, OA minus BA equals to BO. Okay, I'll repeat again. BO equals to OA minus BA. OA is the radius of the biggest semicircle, that is equal to 105 units. BA is the radius of this semicircle, that is equal to 70 units. And therefore, BO equals to 105 minus 70, that is 35 units. We found out that this line segment BO equals to 35 units in its length. And what is the length of this line segment OC? From the drawing it is very easy to see that OC equals to OE minus CE. Again, OE minus CE equals to OC. Repeat again, OC equals to OE minus CE. OE is the radius of the biggest semicircle, that is equal to 105 units. CE is the diameter of this smallest semicircle, that is equal to 70 units. Therefore, in conclusion, we found out that OC equals to 105 minus 70, that is 35 units. So the length of this small line segment OC, it is also equal to 35 units. Okay, in the next step, I presented to you 2 new rules, and we implemented the 2 new rules in our drawing. We have actually rule number 10. According to rule number 10, if 2 circles are touching each other internally, that is to say, the small circle is located inside the big circle, and the small circle touches the big circle at point N. Therefore, they are touching each other internally at point N. There is an internal touch between the small circle and the big circle at point N. So the straight line that connects their centers together, the center of the big circle is at point N, O. The center of the small circle is at point M. And the straight line that connects the 2 centers together is OM, of course. So this straight line OM must pass through point N, that is their touching point. Again, the straight line OM that connects their centers together must pass through point N, that is their touching point. That is to say, OMN is one straight line. OMN is one straight line. Okay? And what is the distance between their centers? The distance between their centers is OM. From the drawing, it is very easy to see that OM equals to ON minus NM. Again, ON minus NM equals to ON. ON is capital R, NM is small r, therefore OM equals to capital R minus small r. That is the distance between their centers, OM. Okay? Then I presented to you also rule number 11. According to rule number 11, if two circles are touching each other externally, you can see here that the big circle touches the small circle at point N. Why? It is defined as external notch. Why? Because none of those two circles are inside the other circle. So they are touching each other externally at point N. Okay? So when two circles are touching each other externally, then the straight line that connects their centers together, point O is the center of the big circle, point M is the center of the small circle. So OM is the straight line that connects their centers together. This straight line OM must pass for point N. That is their touching point. That is to say, O and M is one straight line. Okay? All the 3 points O, N, and M are located on one straight line. O and M is one straight line. According to this rule, rule number 11. So whenever you have an external notch between two circles, then the straight line that connects their centers together must pass for their touching point. In this case, the straight line OM must pass for point N, that is to say, O and M is one straight line. And what is the distance between their centers? The distance between their centers is OM. And because of the fact that O and M is one straight line, it means that the distance OM between their centers will be equal to ON plus NM. ON is capital R, NM is small r, therefore the distance OM between their centers equals to capital R plus small r. Okay, so we can actually implement the new rule number, the two new rules in our drawing. Rule number 10 and rule number 11. Here we have point B is the center of this semicircle, point F is the center of this circle. So if we connect the two centers together, we get the straight line FB. The straight line FB, according to rule number 11, must pass for the touching point, that is to say for point H. Why? Because in this case, the circle and the semicircle have an external notch between them at point H. That is to say, they are touching each other externally at point H, and therefore the straight line that connects their centers together, that is to say FB, must pass for their touching point, that is actually point H. Or FHB is one straight line. Again, FHB is one straight line. And therefore, what is the length of line segment FB, or what is the distance between their centers? FB will be equal to the radius of this circle, that is small r, plus the radius of this circle, that is 70. So in conclusion, we found out that FB equals to r plus 70 units, or 70 plus r units. FB equals to 70 plus r units. Likewise, we connected the center of the smallest semicircle that is located at point D will be the center of this circle that is located at point F. Again, the circle and the smallest semicircle have an acceleration between them at this point G. That is to say, they are touching each other accelerate at point G. And therefore, according to rule number 11, the straight line FD that connects their centers together must pass for their touching point, that is actually point G. That is to say, FGD is one straight line. FGD is one straight line. And therefore, what is the length of FD, or what is the distance between their centers, is equals to the radius of this circle plus the radius of the smallest semicircle. The radius of this semicircle FG is small r plus the radius of the smallest semicircle equals to 35 units. That is to say, FD equals to 35 plus r units. FD equals to 35 plus r units. Then we found out the length of line segment BD. From the document it is very easy to see that BD equals to BC plus CO plus CD. BC equals to 35 units, CO equals to 35 units, and CD equals to 35 units. So in conclusion, we found out that line segment BD equals to 35 times 3, that is 105 units. If line segment BD equals to 105 units. Then we joined the center of the biggest semicircle that is located at this point, point O, with the center of this circle that is located at point F. The biggest semicircle have an internal notch with this circle at point I. That is to say, they are touching each other internally at point I. The biggest semicircle touches the smallest semicircle at point I, at this point. And whenever we have an internal notch between two circles, then the straight line that connects their centers together, that is to say, the straight line OF must pass from point I, that is their touching point. That is to say, OFI is one straight line. OFI is one straight line. And IF is the radius of this circle. IO is the radius of the biggest semicircle, that's equal to 105 units. So, therefore, FO equals to IO minus IF. Again, IO minus IF equals to FO. Again, FO equals to IO minus IF. IO equals to 105 units. It is the radius of the biggest semicircle. IF, it is the radius of this circle, that is equal to small r according to our definition. Therefore, FO equals to 105 minus r units. Okay, FO equals to 105 minus r units. So, in the next step, I've presented to you a new rule, and we implemented the new rule on the green triangle FBD. The new rule is called Stewart's Theorem, and Stewart's Theorem is true in any triangle. So this triangle ABC, could be any triangle. We know that the length of side AB equals to A units, side AC equals to B units in its length, and side BC of triangle ABC equals to C units in its length. And also we have here line segment AO that is equal to D units in its length. Line segment BO equals to M units in its length, and line segment OC equals to N units in its length. Then, according to Stewart's theorem, the following equation is true. That A squared times N plus B squared times N, again A squared times N plus B squared times N, equals to C times D squared plus Mn. Again, A squared times N plus B squared times M equals to C. C is the length of side BC. C times D squared plus M times N. Okay, so we actually implemented the new rule in our green triangle BDM or FBD. This is triangle FBD that I copied from the original drawing. We have already found out, I will not repeat on it, that side FB equals to 70 plus R units, side FD equals to 35 plus R units, and finally side BD equals to 105 units. We also found out that FO equals to 105 minus R units. What is the length of side BO? From the moment it is very easy to see that side BO equals to 35 units in its length. So BO equals to 45 units. What is the length of side OD? From the moment it is very easy to see that OD equals to OC plus CD. OC is 35 units, CD is 35 units, so OD equals to 35 plus 35, that is 70 units. Here OD is 70 units. In the next step we implemented the Pythagoras theorem on this triangle, we implemented Stewart's theorem on this triangle FBD. According to Stewart's theorem, FB squared times DO plus FO squared times BO equals to BD FO squared plus BO times OD. Again, FB squared times OD plus FD squared times OB equals to BD, and inside the brackets we have FO squared plus BO times OD. Okay, so this equation is the implementation of Stewart's theorem on our triangle FBD. FB is 70 plus R, therefore FB squared is 70 plus R squared. DO is 70, so we substitute DO by 70 plus FD squared. FD equals to 35 plus R, therefore FD squared is 35 plus R squared times OB. OB is 35, so we substitute OB by 35. And in the other side of the equation, we have BD, that is 105, so we substitute BD by 105. Inside the brackets we have FO squared. FO is 105 minus R, therefore FO squared is 105 minus R squared plus BO times OD. BO is 35 and OD is 70, so it is 35 times 70. In the next step, we substituted 35 by x. In this equation, we defined x equals to 35, and we substituted 35 for, or any multiplication of 35 by not one number by x. Okay, in this equation. So we have here 70. 70 is 2 times 35, that is to say it is 2x plus R squared times 70, that is 2x plus 35 is x, so it is x plus R squared times 35, that is x. And it is equal to 105 is 3 times 35, that is to say it is 3x. And inside the brackets we have 105, that is 3x minus R squared plus 35 is x, and 70 is 2 times 35, that is 2x. So here we have x times 2x. Okay, after we substituted 35 by x, in our equation we got this expression Then we divided this equation by x, so x here will get cancelled, x here will get cancelled, and x here will get cancelled. What is left from this equation after we cancelled x? We have 2x plus r squared times 2 plus x plus r squared equals to 3. Inside the brackets we have 3x minus r squared plus 2x squared. Why? Because x times 2x is 2x squared. Okay, then we open the brackets here. 2x plus r squared equals to 2x squared, that is 4x squared, plus r squared, plus 2 times 2x, plus 2 times 2xr is 4xr. And we have also plus xr plus x plus r squared. X plus r squared equals to x squared plus r squared plus 2xr. And the other side of the equation we have 3. Here we actually open the brackets. We have 3x minus r squared is 3x squared, that is 9x squared, plus r squared, minus 2 times 3xr is minus 6xr, according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2ab, plus 2x squared. Okay, so we multiplied all the expressions inside the equation by 2. 2 times 4x squared is 8x squared, 2 times r squared is 2r squared, and 2 times 4xr is 8xr, plus x squared plus r squared plus 2xr. Inside the brackets we have 9x squared plus 2x squared is 11x squared, plus r squared minus 6xr. Here we have 8x squared plus x squared is 9x squared, 2r squared plus r squared is 3r squared, and 8xr plus 2xr is 10xr. In the other side of the equation, we open the brackets. 3 times 11x squared is 33x squared. 3 times r squared is 3r squared, and 3 times minus 6xr is minus 18xr. Okay, here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step, we subtracted 9x squared from this equation. 9x squared minus 9x squared is 0, so in this side of the equation we left only with 10x squared, with 10xr, it's 10xr. In the other side of the equation we have 33x squared minus 9x squared is 24x squared. And we have here minus 18xr. Here we added 18xr to this equation. In this side of the equation we have 10xr plus 18xr is 28xr, and it is equal to 24x squared. 18xr minus 18xr is 0. So in conclusion, we found out that 28xr equals to 24x squared. Here we divided this equation by x. 28xr over x is 28r, and 24x squared over x is 24x. So in conclusion, we found out that 28r equals to 24x. Here we substitute x by 35 because according to our definition, 35 equals to x. And we got that 28r equals to 24x, and x is 35. So we found out that 28r equals to 24 times 35. Here we divided this equation by 7. 28 over 7 is 4. So in total in this side of the equation we have 4r, and is equal to 24 times 35 over 7 is 5. So in total in this side of the equation we have 24 times 5. So in conclusion we found out that 4r equals to 24 times 5. And we divided this equation by 4, and we got that 4r over 4 is r, 24 over 4 is 6. So in total this side of the equation we have 6 times 5. So we found out that r equals to 6 times 5. 6 times 5 is 30, so if we found that r, that the radius that we are looking for equals to 30 units. Here, the radius of this circle r equals to 30 units. Okay? Thank you very much.